Okay, welcome. This is a sample presentation that we're going to use for evaluation of a possible future webinar regarding the foundations of Python. My name is Rodrigo Serra, call me Rod. I work for Woken Company in the capacity as technical director, and I've been working with Python since 1997. And today, our idea is to walk you through not just the essentials of the programming language, so people that never came in contact with Python will be able to grasp the essentials of the language, its constructs, and even people that already have some experience in Python. I will try to explore some of the features of the language and explain the reasons why things are the way they are. This is going to be a sample session about 25 minutes long. So let's start. The way I like to do this is very interactive. So if you want to follow through and try out the examples while you're following the webinar, I would recommend you to download Python. So you can download the version from here, the official website. All major platforms are supported. And if you are on a Mac OS X or a Linux system, Python is probably pre-installed, but I'm going to use this version as a reference in the course. So you can use this one. Or if you want to use a more complete package, you can, just a second. I need to time the session so we don't get lost. And if you want to use a more complete environment, another option that you have is to use Anaconda. Anaconda is like a distro of Python the interpreter and many other Python packages that are useful, sometimes trickier to compile. So you can also download Anaconda. They do have a community. They have an enterprise edition, but they also have a community edition that you can download for free. So you can download the community edition as well. Okay, so Python, what we're going to use for this session is basically the REPL of Python, the read eval print loop, and it looks like this. There are many other extensions on the REPL. One of the most famous one is called IPython, which is like an enhanced REPL. You can use that. And there's even a newer form called Jupyter Notebooks. Jupyter Notebooks, created by Fernando Perez, are computational narratives. So they are a tool where you can instantiate a Python interpreter, just like I did right now. And you can type in comments on this environment. So each cell in a notebook is a REPL on its own, and you can create instantiate variables in here. And then you can go back and change the codes and re-execute, or go all the way up, clean it all out, and run all the comments. So this is also an option. So I'm going to use first the standard REPL, which is going to be this guy here. And maybe later we can move into the Jupyter Notebook so you guys have a feel. So what I'm not going to use today, it's a full-blown IDE. There are many. Python comes with one by default called idle. So if you install Python, the standard distribution, and you type idle in the shell, it will open up not just this visual REPL environment, but also it has an editor, and there are some integrations here in idle where you can kind of run and debug programs as well. So it's like a minimum IDE, but I'm not planning to use idle today for our webinar. So most of the time we're going to use the simple REPL, and I'm going to use Python 3.7, which is the latest version of the interpreter. So let's start from the very beginning, which is types. So every language is based on types, and Python has the usual types like an integer, and we can ask for any literal value, what is the type associated to that value. So I create one as an integer, I can do something like this and ask, what is this? And this is a string. So both of these are scalar values that exist in Python, and we have booleans that have this form. Uppercase here is important, is relevant. We have floating point values. We have complex numbers, because the person that created Python, which is Guido von Rossum, he was a mathematician by formation. So he wanted for Python to be an excellent environment for doing math. So in that case, complex numbers are native types in Python. Beyond those basic scalar values, we have aggregational values or data structures that are native to Python. And there's a special syntax to create those aggregated types. For example, the very basic one is lists. So we can create lists such as this one, and I can ask what is the type of this list, and it's going to tell me, oh, this is a list. And I could create another thing. There's an immutable list in Python verbiage called a tuple. So this is a tuple. I cannot mutate anything in a tuple. It's ideal for some functional constructs where you're creating immutable data structures and passing them through. It's very performant as well. And so these are like the bread and butter of data structures. But another very commonly used data structures are dictionaries. And as a matter of fact, dictionaries are in the core constructs of the Python language. All namespaces are implemented as dictionaries. We're going to see that. So let's create one dictionary and attribute to a variable. Let's say that it has key A and value 1 and key B value 2. And then I ask the interpreter to evaluate the variable X and it's associated with the object that is a dictionary, which is this one. And then I ask for the type of the value associated with the X variable. I can see it's a dictionary. It's type dict. So another interesting thing that I can do is probe or introspect on any particular type. So there is a built-in method called dir. And so far, the only built-in method I have used was the type function. But let's use dir, the second built-in method, on top of this object that we have created, that we already know is a dictionary, and see what's in it. So when we do this, we're introspecting, we're using Python reflection capabilities to see what are the protected built-in methods or attributes that the object has, and what are the public. So Python uses this convention, the double underscore, many times called dunder. So if you see on lists or people talking about, you see dunder methods, they're talking about this. They're talking about these standard methods embedded on objects. And when you do not have the dunder, you're seeing actually the public API. Even though all methods are callable in Python. We don't have the distinction between public and private. Everything is callable. It's just a convention where the designer of the object can make clear what was meant to be public. So in this case, for dictionaries, the most common public methods that we use daily are items. And depending on the REPL that you have, you can have completion. So let me quickly switch to another interpreter. I'm going to IPython. IPython is not the standard interpreter. You need to install it. I will recreate the object that we're using as an example. Let's clear this up. So we have this object, and then I want to autocomplete. So if I simply click on tab, then this environment uses the introspection facilities that we just saw and types the method for us. I could even invoke the documentation for this method, saying what this item is. And then I have a documentation for, oh, okay, items is a built-in dict. It's a method for the built-in dict that provides me a set-like object with a view on all of the items inside. So what does it look like? We can invoke the method. And then we see that it's returning this dict item, which is like this view of those elements. And I can convert that response into a list by using the name of the type and applying the name of the type to the return value. So then I'm unwrapping that and having just a single list. And that's true for any type casting that we plan to use on the language. So for example, imagine that we have a string with a number. We know that can be converted into a number. So I use the name of the target type that I want, and I use it as a function for typecasting purposes. So in this case, I can convert a string into an integer, and I could convert the integer back into a string. Another interesting thing in Python, since we're talking about strings, is that it's very flexible in terms of how to use quotes. So I can have single quotes, I mean double quotes. Within double quotes, I can have single quotes without any need for escaping. I can do the other way around. I can have single quotes embedding double quotes. That also works. And there's something very interesting, which is triple double quotes or triple single quotes that will preserve the formatting that I have. So when I create this value, it will preserve the line breaks that we have created. So if you're doing this in your source code, it's an easy, readable way to create multi-line strings. Okay, so we've seen that there are lists, there are dictionaries, but we also have sets. So let's see what are the values that are defined right now. So instead of giving any objects to the dir environment, I'm calling the dir function empty and asking it to list everything that I have. And in that case, there is a lot, because the IPython environment that we're using right now predefines some utilities for us to use, like previous use values, some built-ins, but here we can find the X value that we have just defined. And if we want to get rid of that value in this namespace, we can just say del X, and then it's gone. So if I try to look it up, it's not even there. If I try to evaluate it, it will raise an exception. So everything that fails in Python becomes an exception, and then you have an excellent exception handling mechanism to capture and treat those when appropriate. So let's go to the next part, that we have some functions. I showed you type, which is a function. So if I ask type of type, we see the meta circularity here. But if I ask for what's the type of dir, and then I see that dir is a built-in function or method. So when we start the interpreter, I will switch back now to the standard one, so there's less clutter. When we start the interpreter, nothing is defined. There's nothing yet here, but we already see some objects predefined with some names in the default namespace of the interpreter. And that's exactly how the language works. Because where does Python finds the type function or the dir function itself? Well, it first tries to look on the locals, vars, and if it's not defined as a local, it's try to look in the globals. And if it's not in there, it will look by default on the built-in's namespace. So if I take a look at the built-in's namespace, then we see there's a lot of things predefined in the language. So you can see that the dir function is here and that the type function is here. And because everything in Python is kind of public, one thing that we can do is create something inside the built-ins. When I did that, if I look in that namespace once more, I'm going to see that X is defined in there. That means if I try to evaluate X, it will evaluate, but X is not a local variable. So if I do dir, it's not in here. It's different than if I did this. I'm creating Y as a local variable. If I look it up, I find it. But X is not here because this is the way the evaluation for symbols works in Python. We have the lookup into the locals. So let's take a look at the locals again. So we can see that Y is in there. We can take a look at the globals, and because I'm at the base interpreter level, I'm not in a nested function or anything, then I can find the locals equal to the globals environment. So the Y variable is in both of them. And I can get rid of Y. It's not going to show anymore either in globals or locals. If I try to evaluate, it should raise an exception. But if I try to evaluate X, it's not going to show as an exception because X is still in the built-ins. So if I want to get rid of X, I need to do it on the proper level, which was the built-in environments. So the built-ins, I'm not anymore on the IPython, so I don't have completion now, so I have to type it all. .x. And if I do this, then I got rid of X. And when I try to evaluate the object associated with the variable X, it will look up in the locals, it will look up in the globals, it will look up into the built-ins, it will not find X and raise the exception, name error. This is like very basic, but we haven't touched on other native types, and one it's relevant for us to talk about is sets. So let's say that we create first a list using another built-in function range, and now I will convert this into a list because the range object is a lazy construct that gives me numbers on demand within the range I have specified, but I want to have the full-blown materialize all-in-ran list. So let's attribute this to the variable A. And now I have A as a list. As I have a list in my hand, I can see what are the operations that I can do with that list. There's a bunch of them. I can get things out of the list. I can put things into the list. And Python data structures are all polymorphic. So I can put a string into that list. And I need to mention the position in which I'm trying to insert this list. So let's do it in the first position. Okay. So this is the definition of my list right now. I have removed the number 9 from the end of the list, and then in the beginning of the list, but not in the first position, because in Python, indexing starts with 0. I inserted this new element in the list, and the list became a polymorphic object right now, polymorphic data structure, because they have things with different types. So you can loop over the list, and I can do things that we already learned, like give me the type, or even better, print the type for each element into that list. So now we see that it's polymorphic. And two interesting things that we need to observe in here is that first, Python uses indentation as the way to define scope. So what you're looking at here is that the print command is nested, it's indented. We always use 4 spaces for Python. So it's indented means that the body of the for construct, this loop that many languages do provide, is actually here. And anything, the first line that is not indented would be considered out of the body of the for loop. So this indentation is used all across Python for any construct that has a body. And at first, it's the reaction to using this formatted coding. It seems like a step back to Fortran and other programming languages, but it was a key insight in the language because it makes it less verbose, there's less clutter. The scope delimiters, such as open and close brackets, now can be used for other useful things, and they are actually useful for the compiler in languages such as Java and C or C++, not for real humans. So the first thing we do when we get in touch with a code base in those languages, they're not formatted the way we want, we start reformatting the code. And in the case of Python, almost everybody writes it in the way it's supposed to be written, so it's more readable. So this is a for construct. We see that it's polymorphic, but the other type that we're missing, the other native type, it's sets. So we can convert a list into a set, and then I have this new type. And we can verify that just doing this, and we can even look into what are the useful things that we can do with the set object. And these are most of the things that we can do. So in this first segment, what we have seen was the basic constructs of the language, its basic native types and its color types, and how the REPL works, and the built-in namespace. And next, we're going to explore modules, objects, and some functional constructs. Thanks for watching.